Today we have a very special guest with us, Dr. Valentina Zharkova. She is a professor of mathematics at Northumbria University, also a PhD in astrophysics. A recent paper that she has had published in Nature.com as of June 24th, 2019, Oscillations of the Baseline of Solar Magnetic Field and Solar Irradiance on a Millennial Timescale. Valentina, how are you today?
I'm doing very well, thank you.
Great to have you on. I know you and Mari have had several conversations dealing with this paper, and so today we thought we'd bring you on and once and for all kind of explain a bit about the paper. And there seems to be a little bit of confusion out there, not from this side. We are totally clear on what's going on here. So basically, if you wouldn't mind, I guess we could just start and talk a little bit about the process. You came out with a presentation in October. This was a long process, as is the peer-reviewed journals are. But if you could just kind of take us back to how things kind of started and got to where we are right now with the paper.
First of all, can I tell you that I wasn't so busy with the paper, but with the exam board and marking, finishing, and doing evaluation of my modules. Only now I'm getting towards the paper because it will be reported next week on the National Astronomy meeting. So this is why we eventually prepared the press release, and hopefully it will be going out either tomorrow or Monday on our site and the Royal Astronomical Society site. So we're working on it, and so this is what I started doing. And of course, I was involved with this unexpected, because we didn't have press releases. I thought people wouldn't see yet the paper, but it turned out some people read the journal much more extensively. And so obviously I got involved in some interviews. Actually, it was radio from Manchester who got me on Tuesday even.
I heard that.
Guys.
I heard that. Very good interview there.
Yeah, it was a very good guy, actually. And he interviewed Akasofu. He knew the problem. So obviously it's not only us who understand the problem, there are many others. So definitely this is the happening. So it's nice to consolidate alike people. I really was pleased to speak to the person, I had to say.
So let's get right into it, I guess. First subject I wanted to talk to you about was the super grand solar minimum cycles. I think a lot of folks might have misinterpreted what exactly the definition of the super grand solar minimum. So if you could just kind of tell us about these super grand solar minimum cycles and how this came about.
Okay, so let me explain that the solar activity, this is something which is happening on the sun. And what we done in the previous paper, we detected these double dynamo waves which interfere and produce this grand minimum every 370, 400 years. So this is fine. This is what happening on the sun. On the way, while we're working on this, we managed to derive the formula for these waves. So this makes our life much easier, because now we can calculate this wave as long as we wish. And in the last half year, we calculated it backwards to 120,000 years. So, and when we did it, we discovered that when you look at the summary curve which describes solar activity on the sun, there are patterns which repeat every 5 grand cycles. So every 5 grand cycles we have first cycle slightly higher amplitude, narrower cycle. Second cycle amplitude lower, cycle wider. The third cycle has something also particular. And when you produce this for 20,000 years, you see how you can split them into particular parts,
Okay.
combining 5 cycles, which the shapes repeating each other. So this is the first visual view at this cycle, which really surprised us all. So we thought, oh, what is going on? So we get this 120,000 years of data. So we decided first to see what is this cycle. At that time, it was visual definition, about 2,000 cycle. Can we find anything on the sun? And we couldn't find anything on the sun. Sun walks with 2 dynamo restlessly for billion years and nothing else. So I thought, where this nice pattern comes from? Because when you look at the paper on the, I think it is the figure 2, upper figure 2, the red curve, which shows you nice patterns with the 5 repetitions, and they look very, very similar. If you look at your screen, we put vertical lines to show how similar they are, so visually. But when you see them visually, of course, people would not believe you that you see the same pattern. They say you're making it up. You built specifically this curve to show us pattern. So this is why we started doing statistical analysis of the data. We started applying filter, trying to get this pattern 2,000 years. So we needed to run the filter about 1,000 years to suppress all other oscillations of the 11-year cycle, because the amplitude is biggest. So we wanted to suppress. When you run 1,000 years, it becomes very average magnetic field. And we also played with the 20,000 year filter. So you again suppress all the oscillations. And when you're playing with 20,000 year filter, we discovered this 40,000 year oscillation already seen in our curve between 6. It is figure 1 bottom, which shows you 40,000 years cycle, which is actually, it is the cycle, Milankovitch cycle, because of the Earth obliquity.
Yes.
So the Earth orbit is inclined towards the ecliptic. Now it's 23.5 degrees, but it varies 22 to 24.5. And we discovered that indeed we see in our curve this change of obliquity within 40,000. The period is, Milankovitch says, he calculated 41,000 years, and we see it in our curve. Suddenly this clicked that, oh, obviously our curve has not only solar activity, but because we observe this activity from the Earth, Wilcox Solar Observatory is based on the Earth at Stanford. So obviously we cannot avoid orbital motion effect on this. So we said, oh, what can we see? Maybe these 5 cycles repeating each other, maybe this will be another orbital effect. So this is what we played with the filter about 1,000, and we discovered this very clearly. The cycle of about 1,150 plus minus 95, so we say 2,000, 2,100 years, which came with very high accuracy. So really surprisingly, for all 120,000 years, we got this cycle oscillations, but the magnitude, of course, of these oscillations were by order or even 1.5 order of magnitude lower than oscillation of the summary curve of magnetic field during normal cycles, because it includes solar activity with the big numbers. But when we suppress these big numbers, we discover these oscillations, which is basically of the zero line of magnetic field. So like if you have cosine function, cosine goes from 0 to 1, and then from 0 to -1, and zero line is when y equals 0. In our case, this y equals 0 turned out to be also a little bit fluctuating curve. So it is not exactly straight line. It is like slightly waving.
Right.
So this is what we discovered, that the zero line like trembling, but it trembled in very organized order within period 2,000 years. So at that stage, we of course be very puzzled and started looking what people had, because people are very smart and they already probably look at something. They couldn't explain it properly, but they had intuitive perception they should be right.
Right.
And we found this solar inertial motion, which was very actively promoted by Karvatova from Czech Republic, from Ondřeje, in 80s, 90s, even 2005. She still published, probably now she retired. Before that, in 70s, it was Fairbridge and other guys who we cited in the paper. They first calculated this solar motion, that it turned out that our sun, would they tell us the story about solar system, how it was formed, and the sun sitting in the focus of the ellipse and planets rotate around it in the same ecliptics. It is a nice story for children. In reality, sure. It doesn't, everything doesn't look like it seems. Because first of all, the planets are rotating with some angular inclination to this ecliptic. So what is for us ecliptics, maybe not the same for Mars or some other small angles, 5-3 degrees and so on. Plus, what it makes, the large planets, so they somehow rotate, they made the sun so move around the very center of the solar system. So it turns out, because of this deviation of the orbits from the classic ellipses and so on, that large planets impose that the center of solar system is slightly offset from the center of the sun. So the sun is a little bit, can coincide, but can be up to 2 solar diameters away from the center. So basically it moves on the cycle about 2 solar diameters towards in different part orbits, basically rotates around this barycenter. And so do the planets. So they pretend they rotate around the sun, but what the planets do, they basically rotate around the barycenter as well. And this is what creates a little bit confusion.
Okay.
And it turned out that this is the only effect which can explain possibly this 2000 cycle, because Karvatova and then Palush, he was also working in Czech Republic. They calculated exactly profiles, plus the guys from Australia, whom I cited, and the Kornus calculation, it was their calculation, orbital motion. So it captures many minds. So basically they calculated that indeed the planets make the sun move, not simple in straight line, it just rotates in some like spiral rotation, like we shown in figure 4 in our paper. And because of this one, basically what sun does, if this orbit of the Earth is elliptical and it should sit in the one of the focuses of the ellipse, the sun cannot sit there. It starts moving either closer to apohelium or closer to perihelion. If it moves closer to apohelium, the Earth's orbit becomes more circular, which means that magnetic field become higher because the Earth moves slower in the apohelium and the spring and autumn equinoxes, and much faster during the perihelium. So this is why we have increased, slight increase. It's only, I don't know, even you can say 1% or 2. but it's essential that we have slight increase of this magnetic field because of this motion. And then when it moves in some other periods, moves away from apohelium, close to perihelium, the orbit becomes much more ecliptical, which means that we have much smaller magnetic field because this sun mostly sitting in the focus of the ellipse, and because the main part of orbit of the Earth is far away from the sun, so the magnetic field is decreased. So this is basically was the, I think, eureka moment for us, because what they said that this imposes the period about 2,100, some say 2,400 years, period of rotation of the solar inertial motion of the planets around the sun. We got only maximum 2,100, but maybe if you include quadruple components, maybe we will expand it bigger. We don't know yet. At the moment, as you know, our summary curve is based on the dipole magnetic waves produced by solar dipole. So this was explanation. So basically what this paper says, everything which was said about double dynamo is correct, is happening on the sun, it's beyond our control, it's always happening, and we always have this grand minima every 370 years or 400 years, they will be happening. But on top of this, we can avoid, we can remove ourselves that we are sitting in the Earth which orbiting around the sun, and planets are orbiting around the sun, and they all telling the sun what it needs to do. And this is reflected on this fluctuation of the zero line. So these are two effects which add together, and nothing we can do about it. We need only to embrace both of them, unless we are planning to nuke large planets and remove them from the orbits.
Right.
This is it.
And you know, and the reason why I led off with that concern of the 2,000 year cycle, I think there's a lot of people that misinterpreted it. The 350 to 400 years, the grand cycles, there's 5 of them in these 2,000 year super grand solar minimum cycles. I think some people were actually confusing the term as if it was going to be a much more intense grand solar minimum, a much colder grand solar minimum. People took that word super and thought that it was being referred to the intensity of this particular grand solar minimum, not that it was measured on a 2,000 year time scale. So that's kind of the reason why I wanted to put that out there, to really clarify for people who may not.
The word super is related to the length of this cycle, not to its amplitude, to this increase, because grand cycle obviously has much stronger waves, much stronger activity, because it is real activity, 11-year-old, we can't avoid it, while these 2,000 will have tiny few percent of the amplitude of the grand cycle, but it is essential because the sun physically moves closer to us and further, it affects our temperature. This is essential why we brought it up.
To clarify for the viewers that had some confusion about whether or not we're going into a super grand minimum or a grand minimum, my explanation to them, and I'm hoping I'm reading your paper right, is that the super grand minimum, the bottom out of that was right before the Maunder minimum, and we are coming up out of that, and that is causing that temperature increase.
Yeah, it was a very drop during the Maunder minimum because it was coincidence. It was grand minimum at the same time, and it was super grand minimum. So orbital motion of the Earth and Sun coincided with the minimum in the solar interior by dynamo. So the two coincided. This is why this minimum was so extended and so intense. We will not have for next to 1,100 years, luckily, and maybe the next grand minimum will not coincide with the minimum of these super grand cycles. So we will see.
And Mari makes a excellent point there, because my next concern that I wanted to address is so many people are focused on that warming that we talk about in your paper, the 0.5 degrees Celsius every 100 years, and altogether maybe 2.5 to 3 degrees over the next 600 years. That's all natural. There's nothing in your paper
Absolutely. And done by Akasofu. He was the director of the Space Institute in Alaska, and he published paper 2010, and they crucified him. They couldn't find the reason why would the temperature increase. But he was right. It is increasing. He didn't know the reason, and I'm glad to be able to give him the reason. He retired, but he's still there. Maybe he would read it and he will understand. Yes, he was right. And the reason is because the sun moves physically closer to the Earth, makes our orbit more circular.
Right. It will also be a little bit further from the sun. Is that correct? How I read that in the northern hemisphere?
Again, if it is ellipse, so if it is ellipse, your sun is not in the center, but in the focus of the ellipse, one of the focus. So the focus which is closest distance of the orbit is perihelion, when we have winter in the north. And if the sun is closer to perihelion, or perihelion, in perihelion and even closer, it means that we will have colder winter, because basically we will have less, the sun will not be close enough, will be cold. But if the sun moves closer to apohelium, it moves closer to the center of the ellipse, not to the focus. It means that in the apohelium, the sun will be closer to us, and we will have much hotter summers in the north, while Australia, southern hemisphere, will have much hotter, warmer winters, because they will be closer to the sun in this July period.
Right.
Yeah, while when we move to the December, the sun is still there. It doesn't move so quickly. It needs 2,000 years for it to move. So the sun's still closer to apohelion, so which means that it is further from the nearest point. So in 21st of December, sun is further from the Earth when it would be when it is sitting in perihelion. So basically making the Earth's eccentricity nearly equal to zero, moving to the center, which makes our winters colder, because it is further from the Earth in the winter solstice.
And it's amazing to me that there are some people who actually are more concerned and focused about the warming over 600 years, when we've got to worry about what's getting ready to happen in the next 30 years. And nowhere in the paper, from what I read, does it say anything about warming temperatures in the next 3 decades. So we're looking at the grand solar. And by the way, when we had you on our program 2 years ago, I flat out asked you, are we heading into a grand solar minimum? You answered yes. Today, as we speak, this paper confirms indeed 2020 begins the grand solar minimum period. And so for me, I think what I'm gathering from this paper the most is that we are getting ready to enter in some challenging times. We are going to see colder winters. We're going to see shorter growth. We're witnessing these shorter growth seasons right now. And I keep hearing from people, it's only going to get worse, because this is only the tip of the iceberg, no pun intended. But this is only the beginning of these conditions that we're getting ready to embark for the next 30 years. So I applaud your work, because it's able to look at both sides of the natural cycles, the warming and the cooling. But anything in this paper, to me, I'm taking is a huge red flag and a warning that we have to adapt, and we have to get ready for some challenges here in the next several decades.
Yes, you're absolutely right. Moreover, what in this paper we wanted to say, the Earth is capable to absorb the increase of the temperature, another 253 Celsius, and doesn't disappear. It keep rotating where it is. Everything on the earth keep living because it done in the previous 120,000 years, had 60 of those cycles, nowhere were human interaction, and it managed to survive. So this is the thing. It's not so dangerous to have increase of the temperature. We cannot, if we cannot do anything, then we embrace it and we prepare for it. So this is what my one of the conclusions. So it is not that scary. I don't know if it is. I'm not discussing this global warming human induced, but what I'm saying that the nature has the mechanisms how to handle it, and it didn't handle it because the solar system exists about 4.5 billion years, so we're still there. So it is obviously handling it okay. Of course, our first problem, most essential problem in the next 30 years will be this grand minimum, because indeed, as you correctly said, growing period is very damaged, very reduced. So obviously northern parts, northern latitude, there will be a shortage of some vegetables, fruits,
Sure.
some food for animals and so on, and it will be worsening with every year.
It's going to trickle down. Yep.
Yes, and this is why I don't know how it is in your part of the world, but I had heating yesterday in my house because it was very cold, and it is end of June. I never had it before in my life. It was pretty warm, but now it is not so warm. So obviously it is cooling off. So I don't know who, but what I was trying to say that despite this cooling off, there will be still increase of the temperature because the sun is moving closer to us during the summer. So we might have warmer summer in the next years because simply it become closer. What it says that we mostly dependent on the solar energy and the solar irradiance.
Right.
So it is the main source of our lives, and I'm doubt very much. I don't know. As I said, I will not be advocating the planetary science. People have enough said in the different conferences about CO2 and other, but definitely what we see from the point of view, the system, sun and earth, they worked out very good relationship, and they support each other and survive for billion years.
You know, I've heard several forecasts for the next upcoming solar cycle. There are people out there who actually have forecasted lower solar activity, but still admit that, or they believe that human activity has more to do with the climate. And I really don't want to get into that whole debate because that's right now it's kind of one of those things that it's almost like politics. You don't like talking about it, but I know my understanding is that CO2 does not affect temperatures. And I think that's one of the biggest misconceptions of our time when you talk about the scientific part of climate. I guess the hope is papers like this will help connect the dots for other people out there. And I think here lately, we've seen a lot more mainstream. I've noticed. I know Australia Sky News, they're starting to mention a little bit more about how CO2 is a trace gas. There's a few rumblings here in the States. We're starting to talk about it a little bit more. And I think when people like you, such as your wonderful brain has presented us this work, I think more people like you will be able to help society accept what's coming. And I guess what I'm trying to say is that it won't be so absurd to think, because so many years we've been taught that CO2 causes warming and human activity affects the climate, and that we're just going to burn up as a planet. And if we don't stop emissions, then in 12 years, then we're going to die, or whatever the claim might be. And again, I guess what I'm saying is my appreciation for your work and what you're trying to explain to folks. It has nothing to do about being a whistleblower. This is just you applying your mathematics to your
Yes.
research field, and this is what, and it works. I mean, the spoiler moment, the spoiler minimum. I mean, you've explained already that you believe, and I think a lot of people agree with you that supernova was the reason why we experienced minimum conditions.
Yes, yes, and it was only one cycle which went out, and actually for the same period, remember we put in the paper the observations of the temperature during spur minimum show it was a maximum, while it should be minimum during the minimum of the activity. We know the temperature decreases because solar activity decreased, and so this is very straightforward relationship. It decreased not much, a few percent, but still it should be decreasing, while what they measured it was increased. So it's another issue, but coincidence with many other grand minima, Wolf, Hammer, Maunder, and others, when you look backwards, even the curve which was produced by Solanki in some cases, in many cases we have very similar. When they put the proper background of the cosmic rays, they hit the same grand minima as we did. So obviously we're walking in the right direction, and they walking. Of course, they're affected by the background, which they don't know what was 2,000 years ago or 800. So this, I understand they have the problem. But they think about this current paper, it is not only explains that these oscillations come from solar inertial motion, what it explains that increase of the temperature by itself is not a big deal for the Earth. It can increase by 2-3 degrees because it's already increased by 0.8 degrees from around the minimum. So, and another 2.5, it will be definitely 3.5 degrees by 2600. And because we had about 60 of these super grand cycles in the past 120,000 years, the Earth survived pretty nicely. We don't have any records of during the Roman Empire any cataclysm or other. We remember that during Roman Empire they grew grapes in Scotland, where it's cold and wet now. So at that time it was pretty warm. So it probably explained that, no, you can adopt and it will be nice and warm. So what? It will be probably higher sea level, but after that everything will come back as it was before. So the Earth is stable but dynamic system. So not everything just set up on this same level. And I would be very surprised that the planets are so vulnerable that the tiny amount, which is not detectable even, according to these planetary people whom I read, Professor Salby from, which is Imperial College, and some, it was a conference in Portugal, the people showing different examples, and they sent me the papers proving that it could not be increased. So I trust they're doing proper job. They simply cannot get enough audience to believe to them. But from the general common sense, I would be very worried that the Earth would be so vulnerable that this tiny amount, which we cannot even trace properly, suddenly would send the Earth to the, absolutely disaster. If it was so easier, it will be indeed, the Earth would disappear in the previous 4 billion years, but it didn't. And this tells you that something wrong in this conception. And if you look at the paper by the same Akasofu, figure 9, they show how the people from IPCC extrapolated the temperature increase, and they used the linear extrapolation of the curve, which basically is Doppler curve, has maximum. So you cannot do this interpolation this way, and this is why the increase was 3 degrees, and they start scaremongering and so on. So what I'm saying, that even if we accept, and we know now that the temperature will increase by 3 degrees by 2600, but nothing dramatic will happen because we had this before.
Yep.
We just need to do something else, and this will be fine. This is the point of this.
And that's what I love about this paper, the honesty of both sides of this. There's nothing, you're not trying to support an ice age agenda. You're not trying to do any of that. You're showing us where we could run into a lot colder. And I believe you said that the next minima, grand minima, the 2020 through 2025, is going to be similar temperatures around the modern minimum type.
Yeah.
So, I mean, again, 0.5 degrees in 100 years is not that much increase. And if we look at the data on all these charts, I mean, we've got people arguing about 30 years of information. And the minute we zoom out and look at the 100 years, the 1,000 years, and 2,000 years, then they get upset because that shows, the big picture shows us that we are on a steady, not a skyrocket warming or diving.
Absolutely,
cooling.
we are on steady fluctuations.
Yep.
Also, when I may return to this grand minimum, when we predicted it, when we said that the sun has steady waves coming again steadily in its interior, one at the bottom of Takac line and one close to the surface, and only the interaction changes, so we see different sunspot numbers on the surface. This was a big problem for many people who did different dynamo simulations, because somehow they came up with the idea that the sun is stochastic. So it doesn't have strict rule. It just produces the waves, stochastically. Woke up, okay, today I'm in bad mood, let's produce some sunspot. And then after that I'll go to sleep, I will not produce. No, if this was the case, then if sun was stochastic, then it would be on its last legs to the explosion. Normally all celestial bodies, like human body, they like some steady process. So the human body, if the person had heartbeat with a tachycardia, which is stochastic, so this person is about to die within a short time if he doesn't have stem or something in the heart. The same is with the sun. So what our model explained, that there's no stochasticity. The sun works like hydrogen atom. It produces these waves on the regular basis. The only difference that these waves have slightly offset amplitude and slightly offset the frequencies. And because the waves are interfere with each other, so you have either constructive interference where amplitude increases during solar maxima, or you have destructive interference where waves suppress each other and amplitude comes to the zero. And this is because the waves are of phase, so they periodically, they run into each other every 3,700 years, they come into destructive interference. But it doesn't mean that something changed in the solar interior. Sun even probably doesn't know what is happening on its surface. It producing these regular waves, like hydrogen atom, producing this emission and in the atom. They sit in this wave function, electron sitting on its orbit, and they never change. This is what basically was main outcome of the first paper, that we remove stochasticity. Of course, there are some elements stochasticity because something changing the properties of the media where these big loops propagate,
right,
which becomes later sunspot. And this is indeed needs to be investigated. But after we sorted out that the sun is steady producing these waves, it's much easier to live. We can be confident that it will survive another 5 billion years before it is predicted to explode as another supernova.
Mari, did you
want to? Very interesting. Actually, yeah, the grasping of these cycles for people who aren't well versed with the science behind it. You have your super grand minimum cycle, your grand minimum cycle. You stated that the super grand minimum bottomed out right before the Maunder minimum. We are going into a grand solar minimum that is you're forecasting to be at Maunder level conditions. How do you think the effect of not being in a super grand minimum do you think that'll make it easier? Looking back on history, all the troubles and woes, I mean, we still are facing some major issues, but is it possible to say that since we're not going to be in a super grand solar minimum that we won't be as troubled as people were in the 1600s, but we will have more so concerns with societal issues with food supply and that kind of stuff? Do it make sense?
I believe we will have, it's a good question. I believe we will have slightly less temperature decrease in the current modern grand minimum compared to Maunder. Because at the Maunder, we were at the bottom of everything, bottom super grand cycle. Temperature was 0.8 degrees lower, so everything was a little bit cooler. So with the upcoming grand minimum, we will have slightly higher temperature from which we start from. So definitely decrease of temperature because solar activity stopped.
Right.
Will be slightly less because we already have this gained extra increase. So we have something to lose, which will be easier for us. And furthermore, this grand minimum, which upcoming, will last only 3 cycles, while Maunder lasts for 6 cycles. So we have less time to struggle, which again, very good for us. So we can cope easier and survive everything with the modern technologies, heating and food processing. The problem will be, of course, to provide the food, and probably standard usual resources, growing potato in Great Britain maybe will not be acceptable. You need to grow them further south. And what my talk with the Manchester guy actually raised the question. I said that I've been informed that African countries are preparing actually to grand minimum much better than Europe. Because why they're preparing much better? Because they had snow first time in 150 years since they become measured in the last year. And they were asking me, Al Jazeera, I had a chat with them. I said, it is. I said, yeah, this is coming and you will have more. So they realize it will be cold. But what they realize, there will be much warmer in Africa than up the north in all the northern countries. So they're preparing, African country preparing the agriculture. So they start feeding northern countries and make a huge profit from it. And the guy from radio said they also had information that Chinese people, they're very entrepreneurial, they buy in actual lands and properties in Africa because of it. So obviously people listening what we are saying, not necessarily Western governments, but those entrepreneurial people, they know their time will come and we have no choice to pay. If we want to have potato, broccoli, we need to ask African country to deliver it because it might not grow up, if not this cycle, but definitely the following cycle, 26, from 2030, this will be the worst period. This is when we will be probably begging Africa, Mexico, and others to provide the food. And at that time, I guess the wall in America will work against you because you will be begging Mexico.
And you bring up a good point because some of these other countries are more prepared for this type of event. And you hit the nail on the head. The Western government is not prepared. In fact, when you have lawmakers in our government that want to make rules that will make it more expensive for energy, a lot harder to be able to afford food with just all the politics that's involved with this situation. I'm scared that our lawmakers will take the money that we are spending our taxes on, and where we could use it for infrastructure repairs or maybe indoor grow facilities or whatnot. I'm afraid that there will be lawmakers that will take our money and invest it in things that are supposed to be stopping this, but it won't work, and it'll be a waste of money. I'd rather put a bunch of money into something that could benefit us in the next 20, 30 years instead of fighting a fake battle with a trace gas. So I worry about that here in the United States. And it's interesting to hear you talk about Africa, because when I first started doing this research, a person I was very close to actually was talking about Africa being a possibility for us to be getting food. So you're echoing the same thing that I've heard as well from a trusted source. So it kind of just, gave me one of those, I remember hearing about this. So it's not unheard of for the idea of Mexico or Africa. And I guess that brings me to my next comment, which would be we need to get our acts together and try to find a way to work together, because countries like that, if we're going to have to depend on them for our food production, we really need to start playing a lot nicer with everybody.
Absolutely. We need to be nice to our southern neighbors, that's for sure.
Yep.
Because this is what Earth and Sun teaches the humankind. Be nice to each other, and don't break with your neighbors.
That's right.
Because you might come and beg into them for something.
So true. We hope that it doesn't come to that. We hope that we never have to worry about our neighbors knocking on the door because of how bad things could get. But you're right. We need to be prepared for that. And there's a lot of mentality out there that's, the strongest will survive. Well, that's true to a point, but we also have to unite and help each other. Like you said, the earth has gone through this many, many, many times. It's survived. Nothing cataclysmic happened. We as humans, we will find ways to modify and adapt and, move forward and progress as a species. But with what we have in the near future, we have to get serious, because that could turn into other problems than just weather issues. We can deal with famine, disease, economy issues. There's so many things that are riding on this, and it's important that we all get the information straight and work together.
Yeah, we need to embrace what we cannot change. We can change what we can, but we need to embrace what we cannot change and adapt to it. And this is the point what I was trying to make. Of course, I could leave it, unpublished and everything. And they were saying, reduce the temperature 1.5 Celsius. And then when it will be increasing, that we didn't reduce it and the earth will erupt or explode. What I'm saying, no, it will not explode. It will last very happily after, with increase up to 3 Celsius, because it had it before. Right. It will come in and will go. So this is actually puts back in perspective this scaremongering which comes from the panel saying that it will be too hot and everything. Right. They say it will be even hotter and nothing will happen. So basically, I'm very curious how they start playing it around, that the temperature will be increasing independently of the heating by humans.
Right.
So this is important point. It's not simple that I'm saying this, what I am just delivering, that Earth survived this, and it had many, many hundreds of those before. So now they need to understand that, no, heating does exist. Indeed, we don't object it. But it comes not from the source what they're saying.
Right. That's the biggest part. It's natural, just like the cooling. It's natural.
Yes. It's natural.
And people need to understand, too, once we reach that 2.5 to 3 degree mark at 2600, that's when we'll also start to witness a decreasing of the magnetic field once again. So, again, we're cooling and we're warming and we're cooling and we're warming. And I'm really glad we had a chance to talk today because I think there was a lot of for some reason there were some misunderstanding statements about this paper. I don't see how, but they're out there. And I think you've really done a great job so far of clarifying what we have in front of us in the next 30 years. Do you have time to answer a quick question about pole shifts? I know that's may not be something that you're well versed on, or maybe you are, but we have a question from one of our subscribers. And if you don't want to answer it, that's completely fine. We can edit this out completely. But he asked if the changes in the magnetic field of the sun can have an influence on the pole shift that's also happening. So they're wondering about the magnetic pole shift here on Earth. What's happening with our sun right now? Could that have an effect as well with our magnetic pole shift here?
Possibly. I don't know. I never investigated this problem, but I can... the thinking aloud would to say, when the solar magnetic field is decreased during the grand minimum, so this is the essential effect for the whole solar system. We have the shield, solar magnetic field, which protects us from cosmic rays, from anything. Then this magnetic field will decrease for the next 33 years. Obviously, we will have a huge invasion of cosmic rays coming from anywhere because nothing protects. But it also shows the magnetic field in the planets, which was previously suppressed by the magnetic field of the sun. This suppression will be gone. So what the planets will do with this, we don't know. We will watch it in the next 30 years. I'm very curious to see what is going on, what will be happening. But I'm sure it has to be something different than it was before when magnetic field was strong.
Right.
So this is the key point.
And then that has a domino effect on all other Earth systems, whether it's volcanoes, ocean oscillations, the jet stream, everything. It's such, I think that's the hardest thing for us reporting news on the Grand Solar Minimum channel is it's such a broad area to cover. There's so many different puzzles to put together, pieces of the puzzle to put together to understand what's going on with our climate. And everything sort of is interlinked together. So for us to actually truly know 100% what's going on, you would need a whole team of people with their different specialties. You have like Svensmark with this cloud project. There's groups on like SPACEWEATHER.com, the Earth Sky that does
Dr. Tony Phillips
does cosmic ray.
Yes, I will send you the links to this paper for this conference, which was in Portugal, which planetary people came together and spoke about temperature, carbon, and so on. But probably most relevant to understand what is the effect done by the planet, El Nino, and different parts. Knowing what the sun is doing, you can discuss with them how the Earth responding what the sun is doing. So you can discuss with this. And then of course, the talk by Murray Selby, who explained that there was another guy also in Canada who tells that carbon dioxide, the quantity of carbon dioxide is not detectable. The quantity produced by human is so little that it is not detectable on the background of the general quantity. And carbon dioxide is not all bad because all our trees live on the carbon dioxide. So the more we breathe, the more trees will be growing. Put more trees, it will be perfect. And
that's proven. NASA's shown us maps and satellite imagery that the Earth is greener.
Yeah, NASA is big on that this year and last year about how CO2 is the main cause CO2 is doing right now is greening our planet. You brought up the atmosphere and how small. On Sky News, they did a demonstration. This lady, they poured a bag of rice into a bowl, and the news commentator grabbed just 1 grain of rice and put it on the desk and said that's how much CO2 that Australians are putting in the atmosphere. The whole bowl of rice was the atmosphere, and that one little grain of rice was exactly the emissions. So when I hear people say that human activity has more to do with our climate, I would have to say that that's a little bit false, and I understand that there's people who learned a certain way, but it's just hard for me to look at them as a scientist anymore when they want to try to lie to people and tell them. Yeah, so honestly.
You look at the same happening on Mars. The same, we have polar caps on the Mars are melting at the same time like our Arctic is melting.
Right.
And who is melting them?
Who's driving the SUVs over there?
Yeah.
Or it's the Mars rover.
It has typhoons now. It never had before. It means that its atmosphere is heating as well in Jupiter. Look at this. When you look at other planets, you immediately recognize that we are not capable of doing this. It has to be someone bigger than us. And the only person or subject bigger than us is Sun. Nobody else can do. And this is why we cannot take everything that humankind does. Yes, probably pollution with the bad materials is not good. Maybe we need to reduce pollution because people growing up, having cancer, having different diseases, this would be nice to make it cleaner. I don't mind. This is a good thing. But to assign that the whole humankind and all our industries and all our heating producing this CO2 and planet is literally on the verge of to explode in the next couple of decades, this is a strong exaggeration. I'm just appalled.
You echo exactly what we believe here at the Grand Solar Minute. We agree that we could do a better job at making cleaner air to breathe, cleaner drinking water. We do believe that we do have influences on that. But when it comes to climate, when the information is just all wrong when it comes to telling people that it's your car that's causing global warming or sea rise or anything like that. Mara, did you have anything else that you would like to ask Dr. Zharkova before we wrap it up?
I asked people on Twitter if they had any questions. So would you mind if I asked you a few of their questions?
Yeah, please.
Okay. When I asked people on Twitter, what kind of questions do you have for Valentina? A lot of people asked about climactic stuff, like you're a climatologist, and people don't understand. You don't have that kind of meteorological, I can't say that word, meteorological training on that. You are studying the most important aspect of these calculations that everyone's trying to puzzle piece together, and that is the sun. That's what you are providing answers to in this big puzzle of different pieces that everyone's trying to assemble. So, it is what it is.
I guess climatology absolutely randomly. I was investigating the sun. We had a European project where we done nice automated pattern recognition, a lot of nice data extracted from digital images. So what we done, I was leading the group which is doing this in the digital era. You're trying to bring the proper methods and computers into all the science. So you're not drawing like people before sunspots and counting by hands. I said, okay, we passed the era of drawing. Let's do this computer. So we produced terrific solar feature catalogs and produced the sunspot for the cycle 23. And this is how I got into this subject. So we got these catalogs and we started thinking, okay, we can give it to other people to analyze them, or we can analyze them ourselves. So this is how I started learning what people did before, because I am actually a plasma physicist, theoretical physicist.
Right.
And I'm mostly I do high energy particles. I have papers in Nature for discovering sunquakes, or recently with my PhD students about H-alpha emission. This is why I know hydrogen atom, how it works. So this is my main specialty. But to get into the solar activity, it was as a tale from this big European project. which I didn't want to leave to someone just to pick up flavor of. And this is how we got into it. Even when we done the first paper, I did not realize what effect it will have on the whole status of the climate change, because I didn't realize that these people from IPCC start attacking me personally, like I'm trying to do something with their science. I said, look, I don't do your science, this solar physics. But somehow it turned out they're strongly interrelated. So they dragged me in. And this when I started since then, looking in all this other research in planetary stuff and others, people started sending me their research, sending me the links. So last 4 years was a huge learning curve for me. So I'm getting into the climatology slowly and not necessarily willingly, but I had no choice. Because this is what I discovered, that I can tell people that increase of the temperature by itself is not a big deal. The Earth had it before.
Yes.
And it is still here. So we need to find something else for these guys. And this is what up to them to find for time being.
I'm excited to see people take your paper and do their own research in their own specialties based on the data that you
and
have.
Apply
because
it.
I think once they apply your calculations with a new perspective, we're going to see some really interesting papers that reference yours from this. It's huge.
I would suggest some people should use the magnetic field data from other observatories. I simply don't. They ask, why don't you do this? I physically don't have time. I teach different modules.
Right.
I have projects funded by U.S. Air Force to investigate high energy particles and magnetic connection in them. And we are on this second year of this project, and I work with my postdoc, and I have PhD students. So basically, I'm really tied up, and I have family, of course, my granddaughter, son, and all family. So basically, my time is very limited. So
Sounds
with
like
this limited time, we squeeze free time, not paid whatsoever, apart from donations, and do this research out of curiosity.
Wow.
But that's how we are, though. I mean, I relate to that. It's so time-consuming.
Pushing down, nailing that you haven't done. I become, the more you nail, the law, the more you push, the more is resistance. So this is what I'm working, straight on the physics law.
Wow.
I can't imagine how busy she is. We really appreciate the time that you have given us with this interview. I'm excited to be able to help you with your website. We're working on that. I've told people about that. So,
fantastic.
We're hashing out the technical aspects of that. I'm excited that you are willing to take this time that you're not getting paid for or anything just to help educate people and have people get a grasp on to what is going on. So I'm excited for your website, and I really would like to encourage our viewers to, if you can donate to Valentina, please do. And I'll put the links to everything on the website in the description. She deserves it. Like,
absolutely.
There's so many channels asking for this and that. There's people with fundraisers everywhere. Let's pool the money to people who make a difference, like Valentina.
Absolutely.
Because I really respect your work.
Full time for me, not when I find the time. Then this person could do, like my postdoc, he works his paid salary. So even if I speak here, he's still doing his talk. He has also talk at NAM and everything. He needs to do it, and he needs to work on his CV to get the job. So this is working. But my part in this, I need to find my spare time. I need to finish all the gardening, all the everything, and squeeze the time and start doing it. So you imagine this is only out of curiosity, and only because I feel it is important to explain those kids not even adults, that they were brainwashed to go on this strike because of the global warming. Unless they're planning to, they better go to school and learn astronomy and mathematics and learn that the temperature increase comes from the large planets. So it doesn't matter how long they will sit on this strike, the planets will not move any inch differently.
Nope.
They still will be moving as they should.
Well, it's almost criminal what they're doing, using children for their agenda. They've pushed it to a whole nother level of just disgust in my book.
I don't call it criminal. It is like religion. So they believe in it.
Cult-like.
The religion, and any arguments doesn't reach to them because they believe in it. But what I'm saying, we might not be able to change the minds of all the people, but the young people, they will live through grand minimum. They will live through increase of the temperature. And some of them, the descendant will live to this when the temperature increases strongly. And then they will see it's doable. We can survive it.
But they have to be paying attention. And that's the big thing that we're trying to get people to do, is just to follow it. As complex of an issue it is, pay attention, because there is a huge need for our farmers and people to make these changes, to be able to adapt and move into it. And right now, our farms are underwater, and it's going to be sort of scary over the next few years to see how they adjust.
Yep.
So
some might not even be able to continue anymore as well. So, well, listen, Valentina, it's been a pleasure talking to you. We really appreciate you taking the time with us, answering some of our questions. I think this is going to help a lot of people understand what's going on right now. We do appreciate your time and for you coming on and speaking with us.
Good luck and keep studying.
Absolutely. You're the best teacher we have.
Life is beautiful, but it is complex. And don't be afraid of complexity.
That's good advice.
It is easier to put it, step by step, and put all the complexity into components, and it will become very straightforward. Okay?
Great. Very good advice. All right. Thank you once again, Dr. Valentina Zharkova. Thank you.
Thank you.
Bye-bye.
Bye.
Bye.